Beneath the surface of the Indian Ocean lies one of Earth's greatest mysteries, a place where the laws of physics seem to bend, where gravity itself fails. For decades, scientists couldn't explain it. A massive zone spanning over 3 million square kilometers, roughly the size of India itself, where something impossible happens. Here, the ocean surface dips 106 meters lower than it should. Ships passing through weigh slightly less, and if you stood on the ocean floor in this spot, you would weigh less than anywhere else on Earth. Welcome to the Indian Ocean Geoid Low, the Ghost Ocean. And the answer to its mystery lies not in the water above, but 1,000 kilometers beneath the seabed, in a graveyard of ancient worlds. The story begins in the 1960s, when satellites first began mapping Earth's gravitational field. What they discovered shocked the scientific community. Before satellites, measuring Earth's gravity was a painstaking process. Scientists would use pendulums and ground-based instruments, mapping gravity point by point across continents. It would take decades to map a single country, but satellites changed everything. In 1966, NASA launched the first gravity-mapping satellites. These weren't ordinary satellites. They were precision instruments, so sensitive they could detect gravitational variations from hundreds of kilometers above Earth's surface. They measured how Earth's gravity tugged on them as they orbited, speeding up over dense areas and slowing down over less dense regions. And what these satellites revealed was revolutionary. Earth's gravity isn't uniform. It varies depending on what's beneath the surface. Mountains create stronger gravity because there's more mass pulling you down. Ocean trenches create weaker gravity because there's less mass. Earth, it turned out, wasn't a perfect sphere. It was lumpy, uneven, a geoid, a shape defined by gravity rather than physical features. But nothing, absolutely nothing, prepared scientists for what they found in the Indian Ocean. A zone so massive, so profound, that gravity there is measurably weaker than anywhere else on the planet. We're not talking about a small anomaly. This is a gravity deficit so extreme that the ocean surface literally sinks over 100 meters below the global average. To put that in perspective, that's taller than the Statue of Liberty. The ocean is 106 meters lower there, simply because there's not enough gravitational pull to hold it up. Scientists called it the Indian Ocean Geoid Low, the IOGL, but they had no idea what caused it. The initial theories were wild. Some scientists thought it might be the result of an ancient asteroid impact, so massive that it had disrupted the mantle beneath. Others suggested it could be related to the configuration of Earth's core, perhaps a void or unusual density distribution deep in the planet's interior. There were even proposals that the anomaly was caused by variations in Earth's rotation, or by the way tidal forces from the moon had reshaped the planet over billions of years. Every explanation seemed plausible, and yet none of them fit the data completely. For over 50 years, this remained one of geology's greatest unsolved mysteries. The Ghost Ocean sat there, documented, measured, undeniable, but unexplained. It was a hole in our understanding of the planet we live on. But the real answer, it was hiding in plain sight, buried in Earth's mantle, a ghost from an ocean that died 200 million years ago. To understand the Ghost Ocean, we need to go back, way back, to a time when Earth looked nothing like it does today. 200 million years ago, during the age of the dinosaurs, all of Earth's continents were joined together in a massive supercontinent called Pangaea. It was a world of extremes. The interior of Pangaea was a vast desert, so far from any ocean that rain rarely fell. But surrounding this massive supercontinent was an ancient ocean, the Tethys Ocean. The Tethys Ocean was immense. It stretched across what is now the Mediterranean, swept through the Middle East, and extended all the way to Southeast Asia. It was thousands of kilometers wide and thousands of meters deep. This wasn't just any ocean, it was a cradle of life, home to countless species that would never be seen again. Massive marine reptiles patrolled its waters, plesiosaurs with necks like snakes, ichthyosaurs that looked like dolphins but were actually reptiles, ancient sharks that dwarfed anything alive today. The Tethys Ocean was a world in itself, teeming with life that had evolved over hundreds of millions of years. But like anything in geology, nothing lasts forever. As Pangaea began to break apart, driven by the slow but unstoppable force of mantle convection, the continents started their slow dance across the planet. Africa drifted west, South America pulled away, Antarctica slid south toward the pole, and India did something extraordinary. India, once connected to Africa and Antarctica as part of the ancient supercontinent Gondwana, broke free and began moving north. But it wasn't drifting slowly. In geological terms, India was racing. It moved northward at speeds of up to 15 centimeters per year, incredibly fast for a continent. And as India charged north like a battering ram, something catastrophic happened to the Tethys Ocean. India collided with Asia. The impact was so massive, so violent, that it created the Himalayas, the tallest mountain range on Earth. Mount Everest, K2, the entire Tibetan Plateau, all of it is the crumpled wreckage of that collision. Two continental plates smashing together with such force that the crust buckled upward, creating mountains nearly 9 kilometers tall. But that collision did something else, something hidden beneath the surface. The ocean floor of the ancient Tethys didn't just disappear. It couldn't. When India slammed into Asia, the dense oceanic crust of the Tethys Ocean had nowhere to go but down. It was pushed down, subducted, forced deep into Earth's mantle, sinking into the planet's interior like a stone dropped into honey. This process, subduction, is one of the most powerful forces on Earth. Oceanic crust is heavier and denser than continental crust. When the two collide, the oceanic plate always loses. It bends, breaks, and descends into the mantle, pulled down by its own weight. And that's where it still is today. Over 1,000 kilometers beneath the surface, deeper than the deepest part of any ocean, deeper than the roots of any mountain. A graveyard of ancient ocean floor, slowly dissolving in the scorching, pressurized mantle. For millions of years, scientists knew that subducted slabs existed. They could detect them using seismic waves from earthquakes. These slabs show up as cold, dense zones deep in the mantle. But what they didn't understand was how these slabs affected the mantle around them, how they influenced gravity at the surface. That changed in 2023. A team of scientists at the Indian Institute of Science in Bangalore decided to tackle the Ghost Ocean mystery using a new approach. Instead of just mapping the anomaly, they would simulate it. They would use supercomputers to model the entire mantle beneath the Indian Ocean, recreating 140 million years of geological history. The simulations were staggering in their complexity. They had to account for mantle convection, the slow churning of rock heated from below and cooled from above. They had to model how the cold, subducted Tethys slab sank through the mantle, how it interacted with surrounding material, how it warped the flow of rock over millions of years. The computers ran for months, crunching through equations that described temperatures exceeding 3,000 degrees Celsius, pressures millions of times greater than atmospheric pressure, and timescales spanning hundreds of millions of years. What they found was extraordinary. The cold, sunken slab of the ancient Tethys ocean floor acted like a stone dropped into a pot of boiling water. It disrupted everything around it. The mantle, you see, is constantly moving. Hot rock rises from deep in the earth, cools near the surface, and sinks back down. It's a conveyor belt that's been running for billions of years. But when that cold slab sat at the bottom, it changed the flow pattern. The surrounding mantle rock, heated from below, rose around the slab in massive plumes. These weren't small disturbances. These were columns of upwelling mantle, hundreds of kilometers wide, rising from depths of over 1,000 kilometers. And here's the critical part. These rising plumes were less dense than the surrounding mantle. They were hotter, more buoyant, carrying less mass per cubic meter. And because they rose all the way to the base of the Earth's crust beneath the Indian Ocean, they reduced the total mass in that region. Less mass means less gravity, and less gravity means the ocean's surface sinks. The simulations showed exactly what satellites had measured decades earlier, a gravity deficit of precisely the magnitude observed. The Ghost Ocean wasn't a mystery anymore, it was a mathematical certainty. Think of it like this. Imagine a bucket of water with a heavy stone at the bottom. The stone pulls the water down with its gravity. But now imagine that stone is so cold it creates currents in the water around it, pushing warmer, lighter water upward. Those rising currents are less dense than the surrounding water. The total weight of the bucket decreases. The surface of the water drops slightly. That's exactly what's happening 1,000 kilometers beneath the Indian Ocean. The ancient Tethys slab is the stone. The mantle plumes are the rising currents, and the ocean surface is dropping because there's simply less mass pulling it down. The Ghost Ocean isn't a ghost after all. It's the echo of an ancient world. The ancient Tethys, 200 million years after it ceased to exist, still exerts its influence on our planet. Its floor, buried 1,000 kilometers down, still pulls on the rock around it, still warps the flow of the mantle, still leaves its fingerprint on gravity itself. It's a humbling thought that the ground beneath our feet, the oceans we sail, the very force that holds us to the planet, all of it is shaped by events that happened long before humans existed, long before mammals ruled the earth, long before the dinosaurs walked. The Ghost Ocean reminds us that Earth is not static. It is a living, breathing, ever-changing world. And the changes we see on the surface, the earthquakes, the volcanoes, the drifting continents, are just the visible symptoms of processes happening far, far below. The Ghost Ocean, where an ancient sea still haunts the planet, where gravity fails, and where the boundary between past and present dissolves. 1,000 kilometers beneath the waves.